All right, so welcome to this webinar on Azure Data Lake and persistent staging. Although it says BimlFlex, you could do everything that I'm going to show you today in the upcoming release of Biml Studio. I'm just using BimlFlex because it's already connected to my metadata. So what are we going to do today? I'm going to very briefly go through and talk about what is a persistent staging area, the considerations around it, the difference between the data warehouse and the data lake in the context of persistent staging, and then automation in Azure. So persistent staging, when considering persistent staging for Azure Data Lake or for Azure Blob storage, and considering it for using a database or a database-based schema, there are a little bit of differences. So if we go on the left-hand side here and look at the SQL, when you do persistent staging, you have an up-to-date schema. In other words, if your source system changes a column, a definition, or adds a column to the source schema, you would go ahead and alter the table, create all your packages or your ETL that is associated with you, so your schema is always up to date. The storage, though, is quite costly. You know, we work with a number of customers that do have persistent staging layer, and those databases get quite large, especially if you're going to be tracking a lot of history. And then one of the real good benefits of those is a structured reload of data. Because the schema is always ready, it is a lot easier to integrate the reload process into the next layer. So if we are loading to a data vault or to a data warehouse and you want to reload the type 2 dimension, because you're going from a structured data set to another structured data set, everything works. So your code will just work out of the box. Now on the right hand side here, using a file-based system, what you do is you have schema on read, which means that you would be putting your files into a file structure, whether that is Azure Blob Storage or Azure Data Lake. And when you want to read that data, you need to obviously go and find out what the schema is of the file to load that data in. However, it allows you to rapidly land your data. And when you land the data, you need to do extensive tagging to ensure that the data is usable for the next layer. So as I just said, you need to try and tag with the file the schema that was used to create the file. But it's unlimited storage, and it's fairly inexpensive to store unlimited data and just keep that data for forever and ever. And then schema applied reload. In other words, whenever you want to reload using your persistent staging data, when you want to reload your data into the next layer, you have to go and say for every single file that you are loading, you have to go and apply the schema and then load the file. And I'm going to show you some examples as we go through this. I do remember that I've skipped over this slide, so I'm going to go back one slide just to make sure that we are all aware of what a persistent staging layer is. And I'm just grabbed this from an explanation from Hans there. Persistent staging area is effectively a staging area that is not wiped up. So every time you load, you retain that extracted data, that delta or the full load, and it contains a full history of the source that delivered it to it. So what is the differences between data warehouse and data lake? And again, most of you will be aware of it, but I thought I'll just touch on it in this thing here. As we discussed the data, now in a data warehouse or database, you're going to have structured data that is going to be processed. In other words, it's going to be loaded into that structure. On the data lake side of things, you're going to have structured, semi-structured, unstructured, and even raw data. We are going to focus quite a bit today on the processing, because as I said, and the difference between processing, the data warehouse, you've got the schema on write, data lake, you've got schema on read, and those two, that's probably the main area that you need to focus on when you do persistent staging layer, is to handle that difference. I discussed storage already, effectively cheap storage or inexpensive storage with expensive storage. Agility, well, arguably the one is less agile and fixed configuration. In other words, you need to configure it and structure it. Whereas the other one, by definition, because it is schema on read, you can just effectively dump anything in there. Security, data warehousing and databases are quite mature, whereas your security around your data lakes are maturing at the moment. And the last one here is actually also for me quite important. As we've been working through the data lake and the data warehousing things, we do realize that almost everything we are doing in the data lake space is script based. It's very developer focused and technical. So you have your data scientists and developers access your data lake, and then they need to write the queries, the extracts, and the analysis, and then present the results to your end users. Whereas your data warehouses, it's been around forever, and you can, in most cases, you can really just point some of your business users at a database, and they can use the tools they want and away they go. So there are two different focuses. So for me, the key one that we're going to focus on today is the processing bit. So let's look at a traditional approach, or SSIS. As you said, most of you are familiar with BimL, so you will be probably using or have used BimL to generate SSIS packages. So let's look at a traditional persistent staging environment. And this is just a template, a cut down version of a template we use for BimlFlex. We're going to have data that we're going to read from our source, maybe count some rows, add some auditing columns, maybe add some row count, and then insert it into a staging table. Then what we will do is we will use the staging data or the delta, and we would also merge it into a persistent staging database. So you'll have your data coming into a staging table that gets truncated, and that truncated data will also then go and be persisted in another database. So you'll probably have two tables or even two databases. That's generally what you will also see from here is, because SSIS is very flow driven, it's easy to follow the process. And when we get into the Azure Data Lake or the scripts, you'll see that it's not, and BimL makes this a lot better. But if you were just to develop your JSON files and the scripts for Azure Data Factory, there's a lot of scripts, and they are scattered throughout the process. So let's have a look at a process using SSIS to take data from a source system, and let's say we're going to drop them into blob storage. And we already have this pattern coded up into BimlFlex, and one of my previous webinars goes into into great detail for this. But ultimately what you do when you work with file systems is you are going to you're going to extract your data from any source system here. Could be flat file, SQL Server, MySQL, etc. You are going to want to prepare your data, and I believe that even in the Azure Data Lake space, we are going to want to do this if you have full control over it. And what I mean by that is you're working with flat files, and if you are having flat files, and whether you're using Polybase or using USQL, you want to read that data out of a CSV file. Well, you're going to need to handle commas in. You're either going to need to use a delimiter, and if you are using a delimiter, you need to make sure that you handle that delimiter inside of the text. Then you need to go and say, well, I'm going to have dates coming from MySQL or SQL Server or flat files. Those dates coming into my system may have different structures. So you may want to prepare them and save them to the file that you're going to land in your blob storage in a specific format, a known good format that you're going to be using. If you're using blob storage for Polybase at the moment only supports UTF-8, so you are going to need to convert your ASCII file into a UTF-8. Potentially, optionally, you want to compress that file to save storage on your blob storage. We currently have this optional, and the reason for that is that depending on how fast your pipe is, or your transfer between your data center, or where your source is, to where your Azure blob storage is. If you have a very fast connection, well, you may not want to compress it because you are looking for the speed on read. So when you read those flat files into Polybase, you want that to be as fast as possible. Or you may want to say, my bottleneck is actually in copying this data up to blob storage, so therefore I want to compress the data at source. We then copy the files up to Azure Blob Storage, and then we will use Polybase to load it into either a raw data vault a business data vault or a data mart. So we can go straight from Polybase into your data mart if you are not doing data vault. And then from there, you can do your virtual data mart or a physical data mart and then analytics. That could be ClickView, Power BI. We've got customers using both of those. So that is the process of taking it from source systems into blob storage using Azure Data Factory. And the reason I have simplified this again, I have simplified this quite a bit. The reason for that is that once we get into the JSON files, when I started working with this, I got lost quite a bit in trying to figure out what file did what in what process here. But it's a similar process where you will have your data sources that you will create a connection to, which is called a link service. So think about a link service as a connection to a database or to a blob storage, or to Azure Data Lake here. So once you've created your link services, you create your data sets, and think data sets are the definition of the source and the definition of the file, the destination. So those are the data sets. So you'll have the data link services, and then you create the pipeline, and that will be the Azure Data Factory pipeline that will use the link service and data sets to move data from your database or your databases into either blob storage or into Azure Data Lake. There are many different things that you can do with Azure Data Factory, but this is what we're going to focus on. So, and then from blob storage here, you can go straight to Polybase. You can also use Polybase to go from Azure Data Lake Store using a Polybase connection across to there. And then generally what you want to use here is USQL to do your data lake analytics. So that's at a very simple level, the pipeline that we're going to go for forward. So I'm going to go ahead now and move into the demo portion of this presentation here. So the first thing I'm going to do is I'm just going to go and get some metadata. So this is BimlFlex, our Excel add-in, and all I want to do here is just go and very quickly import some metadata that I can work with. So I'm just going to go ahead here. I've already pre-configured it. Going to go to AdventureWorks LT, and I'm just going to go and grab just the tables here. Hit import, brings all the tables in. I'll set that up, and I've got my columns here, and again I'll process. I'm not going to go into this in great detail here because I can make changes to this metadata. Once I have my metadata, now the metadata here you could connect directly to a database system. But I've chosen to use BimlFlex because with BimlFlex we've already built our patterns that loads to Azure Blob Storage. So here I have my tables that I'm going to create my external tables with. So Polybase, our Azure Blob Storage, Azure SQL Data Warehouse, you need an external table, which is a format file. Think about it as a format that sits over the top of the structure of the flat file. And I'll show you that in action in a minute. So I have my external tables here that I'm going to load from my source to my destination. So that is the traditional approach, or the approach that we use for currently in BimlFlex to go to Azure SQL Data Warehouse. So Azure SQL Data Warehouse templates runs off these external tables that we then load into data marts or data vaults from at the moment. For Azure Data Factory, now I am not going to do a deep dive into Azure Data Factory. Our webinar tomorrow is going to be a lot more focused around the Biml integration of Azure Data Factory. I'm going to do a very high level overview of this, but as you can see here with Biml, again we now have data factories, and in the data factories you can define your link services, and I have these include files. I'll open them in a second. You create my data sets and I create my pipelines. The reason I like doing this in Biml is, as I said, and I'll generate the scripts out very shortly. If you were to go and author the JSON files manually or create them, just the JSON files, you will be flipping in and out of JSON files all the time. So what I'm going to do here is I'm going to just look at my data sets. The link services here is just connections there that I'm setting up to our on-premise service there. And so we are using a SQL Server on-premise, and this is actually running in a virtual machine. I'm going to create an Azure storage, which is my Blob storage, and I'm also creating Azure Data Lake. So I'm going to go from SQL Server on-premise, and I'm going to create a pipeline that is going to move my data from on-prem to Azure Blob storage and to Azure Data Lake. Okay, so that's what that file looks like. The next one here is the data sets. Okay, so here is where, again, where Biml comes in quite handy. So the first thing I'm going to do is I'm going to go and create a for each loop here. So I'm going to go for each loop instance.object. So because I'm using metadata here, and not, so if you were to connecting this, as you would see in some examples, connecting this straight to a database and saying, well, import me all the objects from that database, and then I iterate through the tables that I just imported. Because I'm using a metadata model here, I have an instance. So all of my table, all of my objects that I want to use is already in this, is here. So now I'm iterating table instance.objects, which is, I'm iterating through my objects here. So I'm getting all of these inside of my Biml. So now for every one of those, I want to create a SQL Server data set. And again, I'm going to connect to my on-premise one. And then I want to create the structure of the table. And I'm just iterating through every single column inside of that object. And I'm just need to use the column name and the data type here. And within Biml, we already have the data type mappings. Now, as you know, within Biml, we have the system DB type, but this will be mapped to the appropriate data type that you need for Azure's data factory, the C# system type. So I'm going to go from SQL Server. I'm also creating a data set for my Blob storage, and I'm creating a data set for my Azure Data Lakes. Now, these are just data sets. Okay. Then the next thing I need to do here is, again, I'm going to go into pipelines. So here are the two different pipelines. So I'm creating a pipeline to load my blobs. So I'm going to go from my SQL Server to my Azure Blob, and I'm creating another pipeline from SQL Server to Data Lake. So just with that amount of Biml, I have now created pipelines to move data, all the tables that I want, as many of these tables, this could be 1,000 tables, right? That I'm going to take from my on-premise server, and I'm going to move it to Blob storage, and I'm going to move it to my data lake. And you can, as I said, in tomorrow's session, we'll do a little bit more of a deep dive into these, the Azure Data Factory bits here. And now all I need to do is hit the build button. So when I build this out now, I will build out all of my packages needed to load traditionally, using SIS. I will also create all of the JSON files that I need to create all of my Azure Data Factory assets. So I'll hit the build button here. That's just going to run real quick. I'll open up this SSIS package here, and this will refresh in a second here. Let's have a look at this build, how far it is. While that is building, I'll actually show you the packages. Then now we'll get a refresh button here real in a minute here. Oh, there we go. So the build has completed. So in here we'll have a batch approach that will call packages, and every package will look the same, where we will be just extracting the data. And this is the pipeline that I was speaking about, grabbing the data and putting it into a flat file, then taking that flat file and converting it to UTF-8 and compressing it and loading it up. So I'm just going to go ahead here and just show you that I've got nothing up my sleeve here. So this is where I'm going to be loading it into, and I'll kick off that batch, and I'll go and execute this batch and let that run. Okay, so what would also have happened in that build is, if I look at the output that was generated from the build, you'll see now there's this data factory folder here that will have my link services, my pipelines, and my data sets. So if I look at my link services first, you'll see there's my 3 link services here, and I'll just open this one up just so you can see. I'll drag this across here, and there's the JSON file. And as I said, with when you start working with Azure Data Factory, okay, so that's just the SSIS packages running in the background. You have all of these JSON files. So think about in the context of SSIS, you have one package that have all of these components together. When you work with Azure Data Factory, you have all of these individual data sets here. So for every single table that I've created, I will have a JSON file with attributes here that will tell me what to do. So it's a little bit more, it takes a little bit of getting used to if you come from the traditional SSIS world. Okay, so once I have all of my JSON files here, all I now need to do is deploy this up to Azure Data Factory. And again, I'll show you another script here. So I'm going to head over to our VM here, and I have two scripts here. The first script here, and I'm going to just run this while I describe the script, because the script does take a minute or two. So what this script does is it goes and says all of those JSON files that I've just created, I'm going to go and say deploy all my link services, and inside of that folder grab all the JSON files and deploy them up to Azure Data Factory link service here. The next thing we're going to do is we're going to deploy all of our data sets. So again, I'm just iterating through all of my data sets, grabbing all the JSON files, and then again, deploying them up to my Azure Data Factory. And lastly, I'm going to take my pipelines and grab all the JSON files in my pipeline and deploy them up. And that is the way that that is one of the ways, and probably the simplest way to deploy all of your JSON files. So now this has taken all of that code that we just generated from BimL Studio and deployed it up to Azure Data Factory. The next thing we want to do is we want to execute this, the pipeline here. So I'm only executing one of the pipelines here. I'm only going to execute the Data Factory pipeline here. And I'm not going to go into the script in a whole heap, but effectively I define parameters and I invoke the Azure Data Pipeline. The next bit over here is just to monitor that pipeline, but you can monitor that pipeline using, the Azure Data Factory, the UI also. So again, I'm going to go ahead and just run this, which is going to go and invoke that Data Factory pipeline, and I'm just going to get some pipeline run statuses here in progress. But this is going to go and load that data for me. I'm going to hop out of this over here and back into here. So the first thing I want to do here is I'm just going to go and look at my blob storage. So here are all of my the SSIS packages that just completed here successfully, have now loaded up to Azure Blob Storage, compressed files here. Okay, so far so good. I've pointed it to a source system. I've said to it, listen, get all the metadata from that source system. I might have enhanced the metadata using whatever metadata methods that I want. For BimlFlex, we would do some additional modeling, but ultimately you can connect to a source system, grab as many of the objects or tables on that source system and say, right, run this BimlFlex scripts over here and just start effectively dumping the data into Azure Data Lake storage. Now you will need to do additional things like handling change data capture, having high watermarks and things like that, taking that into consideration. How do you handle changes only and code for that? But effectively now I have my files dropping in there. And that's perfectly fine. Right? So what happens if the structure of your source system change? Somebody adds a column to a table and you now want to have that table with that additional column. Well, you have to say 5 flat files with one structure and 5 flat files with another structure. And you need to be able to handle the change in the structures. So I'm going to do a couple of things here right now. And some of the things I'm going to deliberately make fail so you can see what the error message would look like, and that it's not very useful in a lot of cases for debugging purposes. So one of the things about the tools that we're using for Azure Data Lake or for Azure data projects at the moment is they are probably maturing still. In other words, the debug messages are a little bit verbose, and it's not that easy to understand or debug. Let's go. I'm going to go and connect to my Azure SQL Data Warehouse here. So here I've got an Azure SQL Data Warehouse, and I'm going to use Polybase. So the first thing you want to do when you use Polybase is you need to create an external table. So an external table, think of it as a view over the file. So if the file, you define it with a format, you say to it, the file is in this data source. In other words, it's pointing to that folder in Azure Blob Storage, and you define that using an external data source. The location of it is a container or a folder within that data source. And what is the format? So at the moment here, I have created the file formats that says it's a pipe delimited zip file, gzip file. And once I create that external table, I can then read the data from that external table. So if I just say select star from this table here, I can use normal SQL and go and read from here. So I can go and do this as with normal SQL. However, let's just say I have created an external table here, and I either created the format incorrectly or the file structure has changed. Let me go and run a select top 1000 from this table and see what happens. So I'm running this query now, and it just gives me this this error message down the bottom here, which, as you can see, is probably not the most useful, but it's saying to you that it's expecting a date time, and it effectively got a grid there. So with that message, it says, well, effectively the file format that I'm trying to read is incorrect. And that's probably the simplest thing that I can say there for that. And those are the kinds of messages that you will get if you do not have the right format or structure in place. And this is the same for everything here. Inside of you, when you're working with flat files, you'll have these, I suppose, structured to or unstructured data. You have to take an unstructured file or a semi-structured file and actually read it into a structure. And this Polybase is very temperamental when it comes to wanting data in a very specific format. It's very fast, but because it's very fast, it needs data in a very specific format. And that's how we do that. So the flip side of this is the files that has now gone into Azure Data Lake. So let me go and look at that. So here is my Azure Data Lake here. And I am going to go and explore my Azure Data Lake here. I've just loaded files, and I'm going to look at my customer table here. I should have a file that I just loaded. Now it is this one here. So it's 4:30 in the morning here in Sydney, so it's nice and early for me. But that's the file that we just loaded up there. You'll also see a couple of different more files here. Can I zoom in? No, I can't. So these are a couple of runs that I've done, and this is just the file sitting in my Azure Data Lake storage. Now, what you'll see here in the front of this file here is you'll see this this additional value there. And what we've done there is we are working on our BimlFlex project for the Azure Data Lake stuff at the moment. We realized that we need to be able to differentiate with file structure changes. So let me go ahead and show you this file structure here. So I'm just going to preview this file here, and it's going to come up. Once the data comes up here, you'll see the file structure, and I'm actually going to look at, I think you'll also see that there's no column names here. And this is another thing that you'll need, the reason you'll need metadata with your files. A lot of file structures like Polybase, they don't want a header row. So we recommend not putting a header row in any of our files, and then having the metadata that tells us what's happening in those files, sitting with the files. But effectively, I'm going to get rid of, I think, this column here, column 4. And if I now go back to my Azure Data Lake storage, if I look at this file here, because it's a different format, and again, I'll preview it, you'll see that it's the same data, just I got rid of one column. And that's just, so you'll see here, there's no column, well, so this is Bill Gates here, so there's no additional column here. So there's one column less here, I think. With that in mind, what we now, how do we actually now load this? Now I have, we have started building some of this logic into what we call the Azure Data Factory format files here. And we are now, again, I'm just looking through the instance node here. I'll zoom in here. I'm going through the root node.table. So I'm scanning through all of these files here, or all of these tables here, which is this bit here. And I am creating a JSON format and things. I'm going to just go and hit update preview so you can see the output of this, rather than me going through a whole bunch of code snippets there. So running this, and I'm just doing this for the customer table, I'm saying that, well, I'm creating my USQL format that I need to create a table in. Then I'm also creating my USQL select statement. I'm giving it a format. So what I do is I get the JSON. So this is the JSON of the structure of this table that I'm going to want to output, so that I can read this in and associate it with that format file code there. So I can generate all the code that I need to now load that data from those file structures going forward. Hopefully that makes sense to you. So I have these two different file structures here, and I'll have the different code associated with it. So what I have done is I've created the code here already. And this is, no, so this is the wrong one. So this is the code here. So what I have here is I'm just going to go, and this was code that we generated to say, from the file structure, go and create me a table. So you can create USQL database tables also. So I'm just going to go ahead and just delete this table here. And okay, and also this one. Oops. Right. Oh, yeah. When you do anything, it goes and it submits this query and it starts processing this. Everything is done through submitting scripts and batches. Okay, great. So what I now do is this create table script here. So what you will have is you will have multiple sets of code. So inside of this folder, and I haven't deployed this up here because I'm showing it to you. So what we would have in our Azure Data Lake store here is you'll not only have the files, but you will also have a file called thatcode.json, which will give you the JSON structure of that file. You would have thatcode.usql that will give you the USQL to load that file, and then you would have whatever the format code is that you associate with it, SQL that will give you the external table script. So all of these things, and that's how we are approaching this from a BimlFlex point of view, is because we know that our data changes over time, and then we're going to have, we could have thousands upon thousands of files in here, and maybe 4 or 5 different formats. So depending on what files we are loading, and that's how we approach it. So if you think about this, is now I'm going to create the customer table here. So if I submit this query here, this script here will go ahead and now create a USQL table that I can use to load data into, and then do some formatting. So this is a similar approach if you are used to using tables. Okay, not sure what this is all about. So this would normally create a table inside of this driver database here. Oh, that's why, because I'm not pointing it to BimlFlex. Right. And I want to point it here. And now let's submit it now. All right, that looks better. Okay, so now this is going to go and so this is now going to go create it. Yeah, sorry, thanks for that, Sean. Running demos. I just got Sean just let me know that I'm doing it incorrectly. So now this is going to create a table for me. Now what you then have is you need to want to load that data into that table, or you want to now start processing that data that you've just created. Those files that you create, you want to run some USQL scripts on top of this. So USQL, for those who don't know, when I started, I didn't know, but it stands for Unified SQL. So it's got SQL, some C Sharp, and it is there to combine all of the different big data language together and give you all the functionality. The more I look at it, the more I realize how powerful it is. So now what I've done is, again, we generated this script from metadata because we know what this format code is. let me just, we know what this format code is. We can now go ahead and say this code or this USQL code that I have, apply that only to this format file. So I can read the USQL file and then say, read that USQL file, and whatever is inside of that file, go and execute it. And what would be in that file would be something similar to this. This is not exactly it, but it will go and say, go and look at this, go and look at my customer file, get me all of the files that is of this same format, and go and process them. And then I'm just doing something very simple here that goes and says, well, grab all of the data in there and then output it. Now this script is going to fail, and I've made it fail, and I've structured it in such a way that it deliberately fails. And the reason why I want to do that again is I want to show you what happens if I submit this script, and this takes a little time to run here. It's going to do its thing, but after it's done its thing, it's going to come back with this. No, not with this one, which effectively, let me unpin this here, which come back, and it's very similar to Polybase, where the messages that you get is just, basically the bottom line is that I have the wrong file structure. And this is what will happen if you don't handle the changes in your files. You will be executing USQL scripts, or you will have your pipelines running, and then all of a sudden it'll start failing because, the structure of the file is, or if you are running it and you want to run a big script across all of your data, and there are different file structures in it, you need to accommodate that and bring that data together and that kind of structure. So this is just showing you the drawback of using a file-based persistent staging layer is that you have to handle all of these different changes. In fact, and what we're doing at Verogens is we're actively looking at options and solutions to solve these problems by using scripting inside of BimL Studio. So that's really it. Hopefully what you would have seen here is that Azure Data Lake and using it in conjunction with BimL provides you with the options. And as you said, most of you are already familiar with BimL. I found it, I would say that, because I write a fair amount of BimL in my day job, it was super easy for me for us to create this and understand it and saying, well, okay, here are the things. We spend a lot more time trying to figure out the JSON structure. So, I've got to tip my hat to our development team for putting together the Azure Data Factory stuff here and making it easy for us to create pipelines, data sets, and link services, and much more. As I said, there's a full session just on our Azure Data on the Data Factory BimL components tomorrow's webinar. But it was really easy for me to do this rather than to try and work out all of the different Data Factory JSON components, and then just to create a PowerShell script to copy it up there and then invoke the pipelines using PowerShell scripts. The challenge for us now, building BimlFlex for Azure Data Lake. So our BimlFlex 2018 beta program that we're working on at the moment to incorporate Azure Data Lake and Azure Data Factory as part of our solution. The challenge for us is not the challenge of writing the code. The challenge for us is writing the code so that we can handle these format changes. And that, I think, is the real challenge in using Azure Data Lake for persistent staging. Getting the data up there, that took us probably a fifth of the time it took us to now figure out, once the data is up there, how do we process that in? So our project at the moment is taking all of our Azure SQL Data Warehouse code that we've got for BimlFlex that uses SQL to load into Data Mart and use SQL to load into Data Vault, is to convert that into USQL and accommodating that and making that USQL read the format files and being sort of self-aware, if that's the right word. We're creating Azure Data Lake AI here, if that's the right word I want to use. So that's pretty much it for me. If you have any questions around this, as I said, just we'll be following up over the next month or so as we as we embed more of this code into BimlFlex, we'll learn more from it, and we'll share those learnings with our community as we've done in the past with our other webinars. We will try and share as much of that as we can. So, but feel free to contact us at sales@verigens.com or go to verigens.com BimlFlex. We will be adding a lot more content there around Azure Data Factory over the next couple of weeks. So there's a question here about to what extent is Data Lake supported by Biml Studio and what's only BimlFlex functionality. So all of the functionality that we will have in BimlFlex actually sits on top of Biml Studio. So Biml Studio will support, will have full fidelity with Data Factory, the V2. And what we do at Verigens is we then build templates on top of that to create, as I said, the Azure Data Factory pipelines from metadata. So we will basically just use what we will do in BimlFlex, you can do with Biml Studio. We'll just do all the heavy lifting for you, and that's what we're doing in BimlFlex. How much of the Azure functionality will be available in Biml Express? I think that is probably something for tomorrow, but as far as I'm aware, Biml Express only supports the standard size features, so the Azure Data Factory features will not be available in Biml Express. All right, so thank you for your time. I hope to see you guys, we hope to see you tomorrow in our next webinar around Azure Data Factory, where we will spend a lot more time looking just at the Biml and Azure Data Factory integration and do a deep dive on that. So thanks for your time, and I hope you guys have a good day.